In this example, we are going to explore modular arithmetic a little deeper. If you recall at the start of this chapter, we saw that we do grammar school long division in parts. So for example, we had 256 divided by 17. So if I had 256, and then we use this box and divide by 17, we did the division in parts. In other words, we divided 17 into part of 256, specifically 25. So 17 goes into 25 one time. We then multiplied 1 times 17, that's 17. We then subtract. 25 minus 17 is 8. We then bring down our next digit. Since our remainder is larger than our divisor, the process continues. 17 goes into 86. 5 times. 5 times 17, that's 85. We subtract, and here we finally have a remainder of 1. So we can accomplish modular arithmetic using the same idea of performing the division in parts. And the benefit of doing it this way is if we have really large dividends, we can break them up into these manageable parts. So for letter A here, where it says 21 plus 96 mod 4. 21 plus 96, that's 117. So this is essentially saying 117 modulo 4. 117 modulo 4, well, we'll just do 117 divided by 4. We have a quotient of 29. 29 times 4, that's 116. That's going to give us a leftover, a remainder of 1. So 21 plus 96 modulo 4 is 1. But now let's do it in the parts that are suggested here. So we're going to write this as 21 modulo 4 and 96 modulo 4. 21 mod 4, 4 goes into 21 5 times with a remainder of 1. 4 goes into 96 24 times, and 24 times 4 is 96, so we have a remainder of 0. So this 21 mod 4 is equal to 1. We can use our congruence notation to write this. So we can write this as 21 is congruent to 1 mod 4. And don't forget what this means. This means 21 mod 4 is equal to 1 mod 4. And of course, 21 mod 4 is the remainder you get when you divide 4 into 21. That's going to be equal to 1 mod 4, which is the remainder you get when you divide 4 into 1. So if we took 1 and divide it by 4, I'm going to have a quotient of 0. So using our long division, I have 1 divided by 4. I have a quotient of 0. 0 times 4 is 0. We then subtract, and I have a remainder of 1. So here is a tip. This is a nice convenient way of writing our congruency. So here's a tip. If you have a dividend, a positive dividend that's smaller than the modulus, then the remainder is always going to be equal to the dividend. So for this one, 96 mod 4 is equal to 0. We could write this as a congruence, as 96 is congruent to 0 mod 4. So if 21 plus 96, that's this right here, if 21 plus 96 mod 4 is 1, then we could do the same with the remainders. Then 1 plus 0 mod 4 should also be 1. And of course it is. That's going to be 1 plus 0 modulo 4 is equal to 1. Let's try B. So here we have 31 times 55 times 15 modulo 7. So let's see, 31 times 55 times 15. That's 25,575. So that's the same as saying 25,575 modulo 7. I divide by 7. I have a quotient of 3,653, so I'll take 3,653 times 7. That gives me 25,571. So it's going to give me a remainder of 4. So then 31 times 55 times 15 modulo 7 is 4. But now let's do it in the parts that are suggested here. So we can do this as 31 mod 7, 55 mod 7, and 15 mod 7. 31 mod 7, 7 goes into 31 4 times, right? That's 28. So 31 mod 7 is 3. So then I could express this as a congruency. That's 31 is congruent to 3 mod 7. 55 mod 7, 7 goes into 55 7 times. 7 times 7 is 49. So 55 mod 7 gives us 6. So then I could write the congruency as 55 is congruent to 6 mod 7. In 15 mod 7, 7 goes into 15 2 times with a remainder of 1. So then this can be written as 15 is congruent to 1 mod 7. So 31 times 55 times 15 mod 7 is 4. So then the remainders of the parts should also come out to be 4. So then 3 times 6 times 1 mod 7 should also be 4. 3 times 6 is 18, times 1 is still 18, and 18 mod 7. 7 goes into 18 twice with a remainder of 4. And there we have that. Let's try C. 55 minus 201 mod 13. 55 minus 201. That's negative 146. So this is the same as saying negative 146 mod 13. I divide negative 146 by 13. I'm going to have a quotient. Don't forget we always round down. So I'm going to have a quotient of negative 12. So I take negative 12 times 13. So that's going to give me a remainder of 10. So 55 minus 201 mod 13 equals 10. So now we can do it in its parts. 55 mod 13 and 201 mod 13. 13 goes into 55. 4 times 13 is 52. So this is going to have a remainder of 3. 201 divided by 13 as a quotient of 15. 15 times 13 is 195. So 201 mod 13 has a remainder of 6. This can be written as a congruency. It can be written as 55 is congruent to 3 mod 13. And as a congruency, this can be written as 201 is congruent to 6 mod 13. So 55 minus 201 mod 13 is 10. So then a remainder of the parts should also come out to be the same. So then 3 minus 6 mod 13 should also be 10. 3 minus 6, that's negative 3. Negative 3 mod 13. Don't forget that we have negative 3 is being divided by 13. Negative 3 divided by 13. We always round this down. We have negative 0.230769231, on and on and on. We round that down to the next integer. That would be negative 1. Negative 1 times 13, that's negative 13, but then we subtract. Negative 3 minus negative 13, that's negative 3 plus 13, that's 10, which is the same as what we got here. Now here's another shortcut, here's another tip. If we have a negative dividend, and the base of that dividend is less than the modulus, then all we have to do is subtract the dividend from the modulus. 13 minus 3 will give us a result of 10. Let's try D. 18 minus 22, that's negative 4. 267 times negative 4. 267 times negative 4, that's negative 1,068. So this is negative 1,068 mod 17. I'll divide this by 17. Again, we round our quotient down to the nearest integer. So this is going to become negative 63. So I do negative 63 times 17. That's negative 1,071. So we're going to have a remainder of 3. If we do it in parts, let's do it in parts where we'll do 267 mod 17. And then let's just do this. Let's do negative 4 mod 17. 267 mod 17. 267 divided by 17. That's a quotient of 15. 15 times 17. So we're going to have a remainder of 12. And then negative 4 mod 17. We'll use that tip. All we have to do is, since we have a negative dividend and it is smaller than the modulus, we just subtract the dividend from the modulus here. So this is going to be 13. 17 minus 4 is 13. As a congruence, this can be written as 267 is congruent to 12 mod 17, and negative 4 is congruent to 13 mod 17. So if we have 267 times negative 4 mod 17 is 3, then we can take 12 times 13 mod 17 should also be 3. 12 times 13, that's 156. Divide that by 17. A quotient of 9. 9 times 17 gives us a remainder of 3. So let's try E. 47 to the fourth power minus 12 plus 32. We know that negative 12 plus 32, that's 20. So this is 47 to the fourth power plus 20. 47 to the fourth power plus 20. So that's 4,879,701. So this is 4,879,701 mod 20. Now, rather than this being 4,879,701, what if this was 4,879,700 mod 20? I know 10 divides into this because it ends in a 0. So that means I have 487,970 tens inside here. So 10 is going in here. Also, 10 goes into 20. I have 2 tens into 20. So if 10 is going into 20 and 10 is going into here, then 20 can go into here evenly. So 4,879,700 mod 20 is going to have a remainder of 0. So if this has a remainder of 0, then 4,879,701 will have a remainder of 1. So this is going to have a remainder of 1. So this is going to be equal to 1. But let's check out some of these parts, especially the 47 to the fourth power. 47 to the fourth power modulo 20. We can break this up into parts also. What is 47 to the fourth power? 47 times 47 times 47 times 47. It's just multiples of 47. So let's just do 47 mod 20. 20 goes into 47 2 times with 7 left over. So 47 mod 20 is 7. So then as a congruence, I could say 47 is congruent to 7 mod 20. And since 47, it just keeps repeating itself, then I could say 47 to the fourth power is congruent to 7 to the fourth power mod 20. 7 to the fourth power is 2,401. 2,401 mod 20. Well, what do you know? If this was 2,400, then 20 would go into it evenly. There would be no remainder. But it's 2,401 mod 20, so it's going to have a remainder of 1. So 47 to the fourth power is congruent to 7 to the fourth power mod 20, and they're both going to have a remainder of 1. So 47 to the fourth power, we have negative 12 plus 32, that's 20. 20 mod 20, that's 0. So then I have 1 plus 0 mod 20, that comes out to be 1. So the idea is that when we do it in parts, this is very effective for when we have very, very, very large numbers.